Hi guys, so today I'll be talking about buoyancy and Archimedes' principle. So to start off, I'll be showing you some background knowledge before we get started on our examples. So to start off, we know that pressure exists at all points in a fluid and it increases with depth. So let's say we have a ball. Since the lower part of the ball is at a greater depth compared to the top half, we can say that the upward force is greater than the downward force. Therefore, anytime an object is submerged or partially submerged, there will be an upward force that will act upon the object. We call this force the force of buoyancy. Now this is Archimedes. He proposed that the magnitude of the force of buoyancy is equal to the weight of the fluid displaced by an object. Therefore, we can say that the force of buoyancy is equal to the weight of the displaced fluid, which is equal to the density of the fluid times the volume of the object times gravity, and this is a key equation. This is true for any orientation or shape of an object. Next, we'll be talking about flotation. Why does an object float? Because the net vertical force on a floating object is zero. With that said, we can say that the net force is equal to the force of the buoyancy added to the weight of the object, and it should be equal to zero. Since the force of buoyancy and the weight of the object act in opposite directions, we can say that the force of buoyancy is equal to the weight of the object. Therefore, we can say that the density of the fluid times the volume submerged times gravity is equal to the density of the object times volume of the object times gravity, and this is also another key equation. Let's look at two examples. So first off, I'll be dropping off a marker into my container of water. As you can see, the object floats. Why? Because as we stated earlier, the force of buoyancy is equal to the weight of the object. So the net force acted upon this marker is equal to zero. Also, the density of the marker is less than the density of water. Next off, I'll be dropping in a piece of metal. As you can see, it fully submerges. But why? Well, if we were to say that the object were to be floating, then we would say that the force of buoyancy is equal to the weight of the object. Through manipulating our equation, we end up with density of the fluid times the volume submerged is equal to density of the object times the volume of the object. However, since it's fully submerged, we know that the volume submerged is equal to the volume of the object. So canceling that out, we know that the density of the fluid should be equal to the density of the object. However, since we know that that's not true, we know that the density of the object is greater than the density of the fluid. So therefore, as you can see in the diagram, the force acting downwards is greater than the force acting upwards. Therefore, the magnitude of the density of the fluid is lower than the density of the object. Now let's go through an example. Let's say we have a container of water with water having a density of 1,000 kilograms per meter cubed. You drop in an object of mass 5 kilograms. How much volume of the object is submerged? Well, we know that the force of buoyancy is equal to the weight of an object. We can say that the density of the fluid times the volume submerged times gravity is equal to the density of the object times volume of the object times gravity. We further simplify it down to the density of the fluid times volume submerged is equal to the density of the object times volume of the object. Since we know that the density is equal to the mass over volume, we can further manipulate the equation and equate it to the mass of the object. So since we know that the density of the fluid is 1,000 kilograms per meter cubed times volume submerged is equal to 5 kilograms, we find out that the volume submerged is equal to 0.005 meters cubed. Well, that's the end of my learning object. Thanks for watching.